Hey pre-calcers, I wanted to talk to you a bit about 5.1 practice that was posted dealing with these select problems, and I think you also had to do 13 through 19. I'll be talking through a few of these. I may hop around. If you're still stuck on anything, please let me know if I can help. The first problem I'm going to talk about is showing how sine of x times secant of x equals tangent of x. As we move forward with this video, I'm going to be referencing all of these trig identities which you saw in the initial video. So if you get stuck on anything or you're not too sure how I got it, chances are it's on here. You saw reciprocal identities, quotient identities, Pythagorean identities, which again can be manipulated and worked around. Like for example, you might get cosine squared of theta equals 1 minus sine squared of theta. So be on the lookout for those as we move forward. So what are we doing? We're trying to show that sine of x equals, or sine of x, 1 multiplied with secant of x, equals tangent of x. Okay, so secant of x, we can rewrite that definitely. We know that that's equal to 1 over cosine of x. And just to have clarity on this, we'll keep writing the other side. What do you think we can do from here? Well, we know that sine of x is multiplying with 1 over cosine of x. So if we multiply across, 1 times sine of x is just sine of x. And for our denominator, 1 times cosine of x is just cosine of x. And based off of the identities that we saw, we know sine of x over cosine of x can be rewritten to tangent of x. So we can claim now that tangent of x equals tangent of x. And we're done. So that's pretty much the first problem. Notice how I started on the left. I worked all the way until I got to the right. Hope that helps for problem 1. Let's see, what else can we do? So that was 1. 2 is similar. 5, we can take a look at that because it's combining a lot there. So let me get this out of the way first. Let me see if I can just delete all of this. Figured that they would give a bigger eraser for this. All right. We're getting there. All right, so for problem 5, you're dealing with tangent of x times cosine of x, multiplying with cosine of x, and claiming that it's all equal to 1. So what do you think you can rewrite here for problem 5? Well, tangent of x, you can definitely rewrite that as sine of x over cosine of x, cosecant of x. That can be rewritten for sure to 1 over sine of x. And for cosine of x, you can't do too much there, so let's just put cosine of x over 1. And we should be saying that this is all equal to 1 in the long run. So we have 3 fractions here multiplying. If we were going to bunch all of these up into one fraction, we would have sine of x multiplying with 1, so just sine of x. We would have cosine of x left over. And what do you think for our denominator? What would we have there? Hopefully you're saying cosine of x with sine of x. Can we cancel anything? Sure can. This sine of x can cancel with this sine of x. This cosine of x can cancel with this cosine of x. So since everything cancels, we're just left with 1 equals 1. Then we're done. Pretty simple. 6 is going to be similar to that. Let's hop on over to 7, which is claiming that secant of x minus secant times sine squared of x equals cosine of x. So this is 7. So what's common with these terms here? What do they both have in common on the left side? Hopefully you're saying secant of x. So let's imagine that we take secant of x out. Similar to, think of this as like a greatest common factor, and we're factoring that out. So what times secant of x would get you just secant of x? Hopefully you're saying 1. And then you would subtract, and then what times secant of x gets you secant of x sine squared of x? Hopefully you're saying sine squared of x. And we're eventually going to claim this is all equal to cosine of x. So what do you think about this left side? Can we rewrite anything that's here? Recall from the identities, so this is referencing our Pythagorean identities. In the first video I called it PT, but I just got it confused with Pythagorean theorem, which for this Pythagorean identity, claiming that sine squared of x plus cosine squared of x equals 1. But if we manipulate this and just isolate cosine squared of x, getting rid of sine squared of x on both sides, this leaves us with cosine squared of x equals 1 minus sine squared of x. So we're allowed to rewrite this 1 minus sine squared of x as cosine squared of x. And secant of x, for this, I'm just going to rewrite it. That can be rewritten as 1 over cosine of x. Recall that we're trying to get this all equal to this cosine of x over here. Can we take this further? If we multiply across cosine of x, it's being squared up top. In the bottom, we have just one version for cosine of x. And can we take this further? We sure can. Think of this as cosine squared of x. Really, it's just cosine of x multiplying with cosine of x. So we took this being squared, we rewrote it, expanded it, if you will, and we still have that cosine of x in the denominator. So now what can we cancel? Hopefully you're saying one version of cosine of x. And then lo and behold, we now have one version of cosine of x equals one version of cosine of x. We're done on that one. So that was 7. What else do we got? 9's going to be similar. Look for that identity. Think about how you can rewrite that. 10, kind of the same thing. Let's jump to 13. So we're taking a look at 13. See if I can get this out of the way. So for 13, we have tangent of theta multiplying with cotangent of theta all over cosecant of theta, and we're claiming that it's equal to sine of theta. All right, nothing too crazy there. Bit of a fraction, but that can't stop us. So let's take a look, closer look at this. So tangent of theta and cotangent of theta, I know that and this is kind of a weird one, but I'm just going to leave tangent of theta on its own, because since it's multiplying with cotangent of theta, which is really just 1 over tangent of theta in disguise, we'll soon see a quick cancellation there. Cosecant of theta, I could also rewrite that as 1 over sine of theta, but for now I'm just going to leave it as cosecant of theta because I just want to focus on the top for now. And this should be all equal to sine of theta in the long run. So tangent times 1 over tangent of theta, if you multiply that out, it's inevitably going to get you 1. So that leaves our denominator still as cosecant of theta, and the other side still as sine of theta. How can we rewrite 1 over cosecant of theta now? Well, recall, cosecant of theta can be rewritten as 1 over sine of theta. And at this step, you can probably see that you're very close to finishing this one up. So we can acknowledge that we're dividing with a fraction here, which shouldn't hold us back. We can still work with reciprocals and multiply across there. So what's going to happen here, let me color coordinate a bit. We're going to take this bottom fraction here, take the reciprocal of it, which would give us sine of theta over 1 up top. And then the top numerator, I'm just going to rewrite that here. And then this is going to be pretty simple to simplify. Just multiply across. 1 times sine of theta is sine of theta. 1 times 1 is just 1. And then we're pretty much done. Just rewriting the same thing. Sine of theta equals sine of theta. Pretty simple there. I hope that this video was helpful. This section is definitely tough. And this was problem 13, just to clarify. If you're still stuck on anything, please reach out. If you're not too sure where I'm getting a lot of the information from, chances are it's just from here. Keep this as a